Hello and welcome. My name is Robert and I am a member of the SUSE Rancher community. I'm a technical evangelist here and you're watching part of what we call Summer is Open. Now we understand that summer is not everywhere and we also understand that it's not really open everywhere, but as we're getting back to some semblance of normal and we're opening up in some areas, we wanted to take a moment and showcase some of our open source projects. This is week 3 of a 7-week series that we have. And today we'll be featuring the open source project known as Harvester. And I am joined today by my esteemed colleague, Sheng. Sheng is a senior engineering manager here at SUSE, software architect as well. And he currently leads our Harvester project, which is an open source hyperconverged software built on top of Kubernetes. And we'll be talking a little bit deeper about this. He also leads our CNCF Project Longhorn. And he comes from us through Rancher Labs, which before that he was at Citrix, came through the Cloud.com acquisition and worked on CloudStack and the Cloud Platform project. Before that, he was a Linux kernel developer at Intel, focused on KVM and Zen. And he has worked in the field of virtualization and cloud computing for the last 14 plus years. So Sheng, thank you for coming.
Thank you, Robert.
Now, Sheng, I hear you're a big tennis fan. You want to give us a little blurb about how much you love this game?
Yeah, I think if you're wondering, my level is not really that high. It's like NTRP 3.5 around that time, and it's also like self-assessed. And if you understand what that means, is if you are a half tennis fan, like among the audience. And about tennis, I would say that's really the passionate about sports, and I can just practice on court, shooting, like hitting the ball machines or like doing the serving by myself. And yeah, so like I can just do that nonstop. And if if I have time, like besides the working and the coding and stuff.
I envy your passion. I'm physically only able to do pickleball. Just my old bones just can't handle it. So when I see people who are able to play full on tennis, I dream about it when I'm playing pickleball. So that's great to hear. So couple questions this is part of our Choose Open campaign, but What does open mean for you, Sheng?
Yeah, in fact, coming from, I would say, my whole career, I've been developing open source software, from contributing to Zen and KVM in the kernel and to the OpenStack and not OpenStack, CloudStack, which is OpenStack competitors at the time, and then getting the Rancher Lab and developing Longhorn and working on Harvester, local path provisioning, all kinds of stuff. My whole career is evolving around the open source software. And what I really realized that is when you start thinking about open source softwares, and there are many people, ask me, say, okay, what is your business model? Why you are doing, like your company is doing open source software? It's open source, right? Everybody can get it. They can just download it, and previously they had like a GPL license, which even can restrict how you distribute it. Now the Apache 2 license, the BSD MIT license are mainstream. You basically can use whenever you want. You don't need to even, you only need to mention the author. You don't have any restriction on that part. So how do you do a business? I would say this is in fact a very interesting questions. And on the open, it's not only it doesn't mean like we're charities. We're not just donating the code for nothing. This is the legit business, and the one thing you probably need like aware of is there's so many things in the world right now, and many things become more complicated. And it's not only you have open source, you have the source code, then you can do anything about it. There are millions of lines in this kernel, and unless you are an expert, you don't know really what to do with the source code, right? But you are relying on the Linux kernel and projects like Kubernetes, like Rancher for your daily work. So how do you find you want to realize you want to have this advantage of using those open source softwares, but who else are there going to support you? So one part is as the Rancher and the SUSE, I would say probably most on the Rancher part is we have really open attitude towards the community, and all we do is open source. Everything you can see is from the GitHub. Every workflow and if issue has been addressed or not being addressed, everything is totally transparent. And on the others, the advantage of that is whoever is using your software, they know your commitment. They know you're like, it's in fact just compared to traditional software that in 6 months or 1 year you pop up with new product and stuff. Yeah, and everybody shares that, but they don't know how it works and they don't know what is happening inside. But for the open source software, for the open source software based company like us, you know exactly what is happening inside because everything is happening in the open. And even with the case like a Rancher and Longhorn Harvester, you can also see the progress in the wild. And they are going to drive more adoption for our software. And because that you can see immediately, you can give immediate feedback, and you can say, oh, this is the feature I think you probably will need, and this is the bug I found it. And those things help us a lot on the developer side for us to decide what's the direction we're going to take. We really take those feedback very preciously, and we treat them very important. And because that's the way we absorb the we get help from the community to build this product together. So that's yeah.
Oh, sorry to interrupt, but it seems like almost like a commitment both on both sides, both from the community and us to contribute to make better software for everyone.
Yeah. So the thing is, this is really a two-way commitment. It's not say that we just give away this and we don't take anything back. We take things back. That is your feedback. That's your feature request. That's your bug report. That is you let us help you to troubleshooting this problem, so we can understand what can be involved potentially. I cannot tell you how many times on the open source on the Longhorn or on the Rancher side, users in fact found the bug, like very critical bugs, like ahead of us. We didn't, because there's just limited resources like you can put into the QA and those kind of stuff, and also they just limited the resource like say, okay, I think this is a feature we want to build, but does the user want it? There's no real validation until the user gives us feedback. So that is really important part. I think the open places is not just a one-way commitment, it's in fact a two-way commitment. And our goal is to attract you to commitment more by using our product, by filing bug reporters, by giving out the feedback regarding the features, and even contribute to the code directly, and that will be our benefit, and that's going to benefit both of us, as a company or as end users.
Awesome. So let's move on. Let's talk about Harvester.
Sure.
So what is Harvester? If we want to explain it from a high level, this is of all of our projects, this is one that's near and dear. Before I came to SUSE, this was one of the Rancher products that I was very excited for because it breathed some life into an area where a lot of other competitors just felt it was a commoditized area. And this is a whole new breadth of technology being brought in. So if you want to give us a dive on what Harvester is solving.
Yeah, so very directly, what Harvester is the open source hyperconverged infrastructure software. And when you're talking about hyperconverged infrastructure software, like HCI, you talk about who is the biggest out there. First one is probably VMware. The second one is probably Nutanix, at least in the North American market. And do you know who's the third one? I don't really know.
I don't know.
Yeah. So, but then you take a look at this market, say, why everybody's proprietary? Why there's not really an open source solution out there can stand up to the VMware and Nutanix, right? And the reason is, we think is part of the reason is in fact probably the OpenStack. And yeah, as you might know that for the last 10 years, and there's a lot of resources and in the open source community pulling into the OpenStack, and well, it's been doing great until it doesn't, and that is saying that we saw that there's a vacancy from their HCI solutions, which is supposed to be covered by OpenStack to a certain degree, but that because OpenStack, the promise doesn't really materialize. So there's the vacancy for the open source software there. So you can see all the other places and operation system and all orchestrators and those layers all disrupted by the open source software, but not HCI by itself, right? So we see this is the way, and this is the one thing we can do. And why we decide to do this now is because of Kubernetes, in fact. So the fundamental of the Harvester concept is the Harvester is building on top of the several cloud native technologies, and we're combining them into a single product with great user experience. And the cornerstone of that is the Kubernetes. And the Kubernetes gives us a mature and stable orchestration layer. And on top of that, we have a Longhorn give us the persistent storage layer and Kubernetes and help us with the visualization management layer. So that's the big components with what the Harvester do is we have a turnkey solution for you if you want to operate your VMs in your bare metal in your data center, and we'll have this Harvester here to have this hyperconverged infrastructure software you can just directly install in your bare metal nodes, and you can just spin multiple nodes together and get up, and they become a cluster. That's become the usability changes lead from you have to piece together the pieces, puzzles, and don't know really how they will work with each other to a single solutions that can give you the ability to manage your VMs and other workloads in a single cluster using this Harvester.
So the underlying technology is still Kubernetes. So the operator needs to have a deep knowledge of this, not necessarily any other, hypervisor or HCI software. It's the under the hood. It's still Kubernetes, and it's still operating in that model. Is that correct?
Yes, but we don't expect the operator to really have deep understanding of Kubernetes because the user interface we're exposing to the operators is going to be really agnostic. It's not specific to Kubernetes. You don't need to understand the concept like pods or like storage classes or like system volumes. All of this has been wrapped up beautifully in the Harvester. So you only need to understanding and just see the Harvester UI, which I'm going to do a demo later. You're not going to see any of these Kubernetes terms because we know that one of the barrier for the traditional VM operator to get into Kubernetes is this very steep learning curve you are facing when getting into the Kubernetes. You have to learn all of the terminologies and learn how to deal with YAMLs and how this is all new. So from ground up, Harvester is designed to be a VM operator friendly interface, and you only need to deal with concepts like VMs and VLANs and disk and volumes and those stuff. You shouldn't need to worry about what is underneath. Of course, it's powered by Kubernetes, but your user experience is going to be really similar to what you have experienced with VMware or Nutanix or other hyperconverged solutions. It's not really going to be like Kubernetes central.
Awesome. And from an architecture perspective, you want to show us how that operates?
Yeah. So I think I have something next slide. Yes. Yeah, I think I made a mistake. And just one thing, like you see that on the left side, there's Minion, and the Minion in fact is existing the 0.1 and no longer in the 0.2. But the basic architecture of the Harvester is still the same. And you have the node and running our Linux distro and on the top of the node, and you're going to have Longhorn and Kubernetes providing the storage layer and the visualization layer respectively. And on top of that, you can spin up VMs, and each VM by default, they're going to connect into the management network, but in fact, it's Kubernetes overlay networking. But using that, you can access any VM in your cluster. And also, you can create VLAN networking. This is just a traditional straightforward VLANs. You need to configure your switch for that, but you can have the VM connecting to multiple network at the same time. As you can see on the left side, I have VM connecting to the management networking and the VLAN networking 1, and the second one is connecting to the management networking and VLAN networking 2. And this gives you the ability to isolate your traffic across the VMs. And all of this is pretty much, and the one thing I want to mention is that the multi-NIC, like this feature is also provided by another component, other cloud native technology called MOTAS. This allows us to have the VM connected to the multi-NIC, which is very common cases in the VM operated world.
Wow. And when we look at this here, the Linux distro currently is K3 OS is where we're currently sitting on top of right now?
Yes, for the 0.3 and the underlying Linux distro is K3 OS, and we are going to change that in the 0.2, this K3 OS, but in the 0.3, we're going to change that into another OS. We don't really have official name yet, but that operation system is going to based on the best SUSE technology, which is SUSE Enterprise Linux. And that provides a very stable foundation on the OS level, and we don't need to worry too much about how OS is stable or not and the compatibility stuff, because that is all covered by the SUSE Enterprise Linux, and we're using some derivative version of that. And on top of that, of course, we're running Kubernetes and then the Longhorn Kubernetes. And just to clarify, in fact, I got this question, which this is something interesting, because I create an issue in GitHub, say replace K3 OS, and with one line of expectation saying that K3 OS is never supported, so we're going to replace it. And since this triggers some speculation about what's the future of K3S, which is the Linux like the Kubernetes distro used by the K3 OS, and the short answer is, don't worry, it has nothing to do with K3S. K3S is still the star project in the SUSE and the Rancher, so it's not going anywhere. The only reason we're replacing K3 OS is K3 OS is not the only part with K3S and K3S. Only common part is K3 OS using K3S as a distro, but on OS part itself, K3 OS lacks of many capabilities we want, so we don't and also it's not really a supported operation system, and never been a supported operating system in the even for the Rancher. So that is why that we're going to replace it and using some supported technologies at some derivative from the SUSE Enterprise Linux to make us in the future and make sure we can really support it well. And another thing I might want to give an update is we're also going to move into the RKE2, which is instead of K3S. And K3S, in fact, is an upstream project for the RKE2. And RKE2 is designed to be more enterprise focused and with building MOTAS, support and have a lot of other pieces to make it more easier to run on an enterprise grade environment. But on the upstream, say RK2 basically a derivative from the K3S as well. So don't worry about K3S. Even now, in the next release, Harvest we're not going to use K3S directly, but it doesn't mean K3S is going to anywhere. It's still the one key components, which is the RK2, which is Harvest is currently going to use in the next release.
Awesome. Well, can we talk about what was just recently released? I think you guys had a release back in April?
Yeah, the April release is 0.2, and we are currently really working hard toward the next release, and that is 0.3. And the 0.2 release, we have implemented many critical features like live migration, which is you can also probably know it as vMotion in the VMware world. And this allows you to migrate a VM from one node to another without downtime. Personally, I think this is one of the key features to really differentiate from the pod workload in the Kubernetes to the VM workload. Because once a pod started in the Kubernetes, you can either be stopped or migrated. Those things cannot happen until you decide that you are willing to disrupt your workload, right? Then it's going to make it hard for you to really maintain your maintain your node. Of course, you by principle, you should design your workload to be like distributed, cloud native, and also stateless, and with like state, probably stateful, and then the stateful need to store the state out as well and stuff. But in general, it's really still a very good idea if you want to, for example, performance OS upgrade for a certain node, and you want to do maintenance operation. It's going to be much easier for you to still keep your workload live rather than have to kill them and restart them again, like the drain process in the Kubernetes. And the second feature we have added is the backup restore for the virtual machines. And in fact, this is an extension of the feature inside Longhorn. So, Longhorn has been GA'd since last year, and the backup restore, in fact, is one highlighted feature in the Longhorn that enable you to back up your data to the remote S3 or NFS server, which is going to be offsite. And in this feature, we have extended that. We have using the Longhorn backup restore feature to implement the backup restore for the Harvester VM as well. So the next thing is also very big. So for the 0.1, we still only support the file system and as the backing device for your VMs. On the 0.2, we have in fact supported the raw block device, and you now can attach a native Longhorn performance block volume into your VM. And also we have done a lot of optimization around that part. So there's one key feature in Longhorn called the backend image, which allows you to create, to have an image like stored locally and then create a volume on top of that with a very thin read-write, like a copy on write layer. So whenever you have for example, you have a image which is like OpenSUSE, and you want to start 10 VMs on 3 different nodes, right? With this feature, and you don't need to store that probably 2 GB of OpenSUSE image on every single replica, which is going to be like 10 times 3, which is 30 replicas, which end up costing about 60 gigabytes, right? If you just copy the images every time when you create a new VM. With this technology, you only need to store a backing volume on each node, which if you have 3 nodes, going to be 2 gigabytes each, in total 6 gigabytes of the space, and all the other volumes like VMs creating on top of that, we're going to use that image as a base image, so they can just always still read, write, and do a backup restore as usual, but they don't need to. They are going to share this same VM image on that node. So that's increased the storage efficiency to a great degree. And the last thing we added in last release, in fact, is also critical, which is PXE support. It's going to be, so in the 0.2, you can do installation use through the PXE. Before that, you can only do installation by loading the ISO into your node and then boot up your node, just like how you install normal Linux system. But for the 0.2, the PXE support makes it easier for you to deploy Harvester in your data center. So that means that you don't need to really go into, if you have 100 machines you want to install Harvester, you don't need to using IPMI and load the ISO dynamically every time and go through the installation process manually for each individual machines. You can just using the PXE support feature and set up PXE server and just install them all at once. So that is a dramatic productive improvement on how easy can you install Harvester.
Awesome. So can we talk about what's coming up in this big 0.3 release?
Yes. So I think that's in the next slide. Or yeah, okay. Yeah, glad this went as I expected. So we currently targeting the next release 0.3. It's on the Q3 this year. Wow, this is really a laundry list of new features we are going to add. And the first thing is we are going to integrate multi-tenancy support, and this is going to be with the help of the Rancher integration. And replace K3OS, as I mentioned before, is also a very important item. It's not going to be really visible from the user perspective, but the underlying structures need to be changed a lot to accommodate that. And we are also going to provide a built-in load balancer, built-in highly available load balancer. In fact, that is based on the KubeVIP project. That enables us to have a load balancer for the developmental harvest clusters. Sorry, as well as the Kubernetes clusters you're going to create on top of harvest clusters. And other features like monitoring, logging, and those will be added, and the multi-disk management, which enable you to fully utilize whatever hard drive you have on the node instead of on the root drive we have like in the 0.2 release. And we are also create an end-to-end test framework, which is going to really help our feature development, because that's going to cut out any regression and stuff that's running continuously to make sure the product we deliver is on the highest quality side.
Wow, and you're shooting for GA the next quarter after?
Yes, currently we are shooting for GA on the Q4 this year, and just a word of caution, all of this are really tentative because the project itself is really moving fast. There's no as many components like we still need to work on, and there's going to be many challenges for us to hit this, but yes, so this is still the target.
Awesome, awesome. Well, without further delay, can we see Harvester in action?
Oh, sure. Okay, let me share my screen.
And you should be able to share it now.
Okay. All right, can you see my screen?
Yes, sir.
Let me see. Okay, so this is in fact an internal setup. As you know that I have get within one of our data center, and this is the 0.2 release. So now Harvest only support username, password, login, and in the 0.3 release, if you are managing Harvester through a Rancher server, you are able to use the whole Rancher authentication as authentication framework, like any auth, like probably any known auth provider can be used, and also the authorization like our back rules will be applied as well. So that's login. Okay, so now what you see is the dashboard of the this Harvest cluster, and you can see now we have like three nodes right now, and we have 2 virtual machines and 2 network created, and the 1 images, and so on. And you can see what's the current status of the CPU utilization, memory, and the storage. And some things happens here, and this can be a reference to see what's the latest activity coming. And to the host page, you can see that these are 3 nodes we have here. Let's just click into one of them. So now you can see all the information regarding this host and what's the operation system, since it's still like 0.2, so it's K3OS, and the VLAN network has been configured on each H4, and those other informations. So I don't think we have any virtual machine on this node, so let's jump into the virtual machine. So for this demo, I have created 2 virtual machines, and this is how you when you see the list of virtual machines, and you can click into them. And this is obviously this one is running with the OpenSUSE lib 15.2 and the QCOW file. And what's the IP address you can see from here, and what's the favor, which means the configuration, and it's 4 CPU, 4 GB memory. And so from the volume side, we know this one has been assigned with the 10G volume as the root disk, because of course you need a root disk, right? So on the network side, this one doesn't only have the default management network, and which is the like 1052 at this point, and doesn't have any VLAN network set up here. I don't put any SS key here because I can log in with the console. And also you can see in order to set up this cloud instance, which you probably notice that this is the cloud image, right? So this is cloud image, so I can set a password from here, and also what's the network. And the only thing I specify here is I ask the OS to get the DHCP address from EZ0. All right, so there's some other tabs than the event and migration, which is tied to line migration implementation. So let's go back to the virtual machine and see how that looks like. So in order to access this virtual machine, you have the console. And this is going to connect it to the VNC console of this VM. So I can just like log in with, I believe that it's OpenSUSE, and the password is the one I have reset in the cloud config, so that is password. So now you are in this virtual machine, and you can see there's one NetZero, which is available right now, and you can ping google.com, and of course, because this is like netted to the outside. And also, let me see, is this? Let me see, I can see top, right? Yeah, so this has been assigned for the CPU and memory. I would say nothing of this should be a surprise to you because, well, this is in fact underneath is a KVM virtual machine. You get whatever you can get with KVM with this. Okay, so let me switch to another one. And this is another virtual machines we have is the NetZero, and only thing is different is this one is configured with the VLAN network in 91. So if we go inside the VNC console, you can see this one in fact have two NICs. Another the EZ1 is VLAN connected is to the 172.16.91.45, right? So that is the IP we got from the DHCP server for the VLAN 91. And how do we know this VLAN work? So let me try. Now this is 45, right? Okay, let me try to create another virtual machine, which I can call it leaf03. I'm still going to give you the full CPU and the full GB of memory, and I'm choosing the leaf as the image. And on the network side, I'm going to add another network, which is also VLAN 1. And the advanced option, I'm choosing the password, and I'm going to choose the double NIC for the network metadata. And this is going to ask this cloud image. When I put up, they're going to get IP from both EZ0 and EZ1, and then I just bridge. So let's see how long it's going to take. As I mentioned, one thing we greatly improved in the 0.2 is using the adding the raw block device support, which makes it very fast for you, very easy for you to share one image among the different instances. So that should be like bring up very greatly speed up the starting process. Okay, so why is it not there? Yeah, I think it's still doing it. 30 seconds. So in the meantime, we also have a feature, as you can see in this console, you can in fact select web use VNC, which is how you click it. And this is also a serial console. And you can log in case like somehow your VNC crashed or you want to get some kernel information. And you can also log in here. Oh, I typed the wrong one. Yes. So this is everything like streaming from the serial console. And if we are operating VMs, you know how important this is to access into the serial console in case you are in some trouble. So this gives you a way to do that.
Wow.
So that's go back and see. Okay, lib3 is on. Let's take a look. All right, so this just finished the configuration, and I think cloud config has been applied. So let's see. All right, it's up, and in fact, this one, as I mentioned before, I put into the VLAN 91. So currently get IP as 172.16.91.64. 46. And if I remember correctly, previously the node is the 172.16.91 at 45. I can ping it. Yeah, I think they're connected. Yeah.
Wow.
Okay. So that's for the virtual machines, and on the volumes, in fact, you can see all the volumes like associated with those virtual machines, and you can do, in fact, you can do the snapshot backup, like a backup on here, and you can try to do the migration. In fact, let me try if this migrate works. I hope it does. Okay, migrating. In fact, in the meantime, let's try something else. I remember that IP is like a 46, right? On the VLAN networking. So let's see how the migrate works. This one is the 45. Okay, still pingable. Still migrate. Oh, sorry, I think I'm too late.
Did it already migrate?
Yeah. Yeah, I think it's already migrated to the 01. So yeah, sorry, I'm too late. So this you can see previously. I think let me see if I see information here. So previously, this migration happened from demo 02 to demo 01, and now, yeah, I think it's probably still running there. Yeah, the ping is still running. Okay. Yeah, I used to use, I was planning to demo that. You can see like probably ping stop for a second because you need to have network transmitted to another one. But yeah, sorry, I'm a little bit late on that one.
Wow.
So that's for the volumes and virtual machines migration. And for the image, it's very easy, and just you can just create an image here and just put whatever URL, and like you can find something like let me see. I already have OpenSUSE, so let me try Ubuntu cloud image. And go with focal one. Current. Okay, which one is this? I guess this is probably the one. Yeah, I think this is the one. So let's just put it there. And once you put the URL here, they click create, and we are going to import this image into the system. And I should be able to create a VM right now. And yes, this is the one we just imported, and oh, sorry, give me a moment. That one needs a special configuration. I need to find where that is. Yeah, because Ubuntu and the SUSE are using different nicknames, so I need to make sure the nickname is right. Let's click create. Yeah, so now, in fact, we are downloading the image from the internet in the backend. So this is going to take slightly longer than what happens on with the lib one, because that one already caching the image internally in the system. So that's come back to that later. So the template is the one you are using if you want to start Windows or like want to use the ISO. You can also specify, say, the image name in the template as well. And this is pretty much standard for any VM-based operations. I don't have any backup set up right now. If I do, and this is going to show the backup store. And just in case you want to see how the backup and the restore and all the other function in real action, we do have a session like happened probably a month before, and have all that in detail. We're going to share the link at the end of session. So on the network side, I have VLAN 91, 92, and on the SSH, I haven't added anything yet because I'm used to use the console to log in. And the cloud config template is basically a shortcut for you to fill in the user data, network data for the cloud init. And of course, we have some settings information here.
Wow.
All right. Let me see if this Ubuntu is up. Okay, this Ubuntu is up. Oh, okay. So that's the one thing about Ubuntu Cloud Image is they don't show a thing in the VNC console. So that's why you need the serial console. And you thought it's hunting, but well, it's not. It's still like loading the cloud init and set up everything right now. I think it's that thing that's down, and I need to log in.
Do you remember the default username and password?
Yeah, so the username, I think is Ubuntu password. I have just overwritten that using the cloud image. So, okay, it scares me a little. I thought say, why it doesn't show up? Okay, so IP, already get IP on this one. I suppose this can like ping Google as well, access to the internet, all this thing works. All right, so that concludes my demo. Hand over back to you, Robert.
Thank you, thank you. Well, let's take some questions from the audience and see if we have any. Let me look here. Oh, there's CK.
Hey guys, yeah. Hey Sheng, there's a lot of questions about hardware config. Somebody did comment that we posted a blog about hardware, and Jamie Phillips kind of showed up what he's doing in his home lab. So there is a blog about that in community posted this morning, but questions are kind of like, what's the minimum hardware setup we need to make this work?
Yeah, so in general, Harvester doesn't really require high-end setup, but if you want to run a single node, it's probably possible if you want to run like a nested visualization in your Linux environment with Kubernetes, and you can try it out. It's not officially supported, but for the production workload or you want something really decent, we recommend you have at least 16 cores, and you have to have the SSD or NVMe drive, because we are using SCD, which is really intolerant for the latency, and of course that's the building stone for the Kubernetes. And another thing is the Longhorn also is optimized for the SSD and NVMe's. So just say give that enough CPU, like 16 cores, and then you can start, and also SSD and decent amount of memory like 16 GB, those kind of in those kind of spec, and then you should be able to start a few virtual machines as you wish. And if you want to have a multi-node cluster setup, it's better to have at least 10 GB network. 1 GB works, but it's going to be really going to be tight, because like Longhorn is network, it's like software-defined storage. You're going to have every time you write something, you're going to have traffic generate on the network. And the 1 GB network is essentially just 100 megabytes, around 128 megabytes per second, and that is nothing to your underlying SSDs.
So that kind of brings up, our challenge in the community with these events, with any event in community. We want to have a challenge, something that takes it. Users and community members can take away and go and play with these projects and get their hands dirty with that. But because Harvester requires so much hardware, challenge is slightly different because not everybody has an extra machine laying around to go throw this on. And I attempted to, try to virtualize this on a Mac, and it didn't work as well as I thought. So that being said, our challenge this week, and it's going to go for the summer, is kind of showcase your Harvester Home Lab. So if you have an extra machine, you have some spare hardware, and you want to get it up there and running, post a picture of your setup, your Harvester Home Lab on community.suse.com and DM me your address, and we'll send you a sticker with a Harvester sticker so you can put on that machine and show us that you're running Harvester in a home lab. I personally did it. I followed Jamie Phillips' posts, which you'll find in community.suse.com, and I went through the entire thing, and it was much faster install than ESXi and VCSA. That took me about a day to install and configure, where Harvester I was up and running in about 15 minutes. So for community members, you'll find that link on community.suse.com. Jamie Phillips wrote a blog about it. And like I said, if you post your Harvester Home Lab on community, we'll send you a sticker.
All right, that sounds great.
Who doesn't want a sticker? It's so cute too, right? It's nice green. Cool. Hey, there's a lot of questions. We'll try to get to a few more. So Mohammed was asking, hey, so even if you don't know how everything is working under the hood, is it still easy to debug and locate the source of the error?
Yeah, that's a very great question. So so basically under the hood is going to be Kubernetes. So in order to debug it and you see something is wrong, and you probably still need to have some knowledge is what is powering it. But in general, you should be able to see some error message from the event. And also, the one thing we introduced in the 0.2, and we continue to do it, is the support bundle. So you can, if you take a look at the Harvester UI on the bottom, on the footer of the UI, there's one button called Generate Support Bundle, and that is going to connect all the necessary logs and the YAMLs and to a zip file. And you can either analyze the zip file by yourself, which you probably can, if you have familiar with Kubernetes, you can find what the issue is and stuff. And or you can, if you need some help, just send that and to the Harvester community, which is you can reach out to us on using the Slack or at GitHub/Harvester, file the issue there, and have the information attached that we can help you take a look and see what's going on. Yeah, so most common issues we saw so far is like probably as Robert mentioned, and you're trying to run Harvester in some nasty virtualization environment. For example, VMware Fusion on Mac, it doesn't work, and complaints about the hardware problems. Yeah, unfortunately, that's not really supported. And we know that the Harvester works on the Linux machines with libvirt and KVM nested virtualization, but we never tested or on the VMware Fusion and stuff. And well, if I take a guess, I'm going to blame on VMware. Yeah. So because we just use KVM, we're not really special. All right. Yeah.
All right. Cool. You got one, Robert?
Yeah. So Sheng, we talked about what's coming in the next 0.3 release. Of all those features in there, which one's the one you're most excited about? Because for me, it's probably going to be monitoring, because I like to see what's going on in there. But I wanted to get your point of there's a lot of features that you guys are coming up with the 0.3 release. What's one that you're looking forward to the most?
Yeah, I would say I have a slightly different opinion than you, Robert. So monitoring is very nice, and you can see all the things. But the one thing I'm really excited is the integration with the rancher. And just to be clear, that rancher is not whatever we're running, like inside Harvester is going to be a separate thing. But that rancher, which is going to have the ability to manage multiple Harvester clusters, and you can also have authorization, authentication through that rancher, and basically whatever configuration, whatever credential you have on the central rancher can enable you to access the UI of the downstream Harvester clusters. And all of these features make it very powerful for you if you want to deploy like multiple Harvester clusters and the management different locations. And also, if you want to give some users access to only certain cluster or only even certain like a project, which is a concept in the Rancher, and that is the RBAC rules are going to be integrated there. And also, a very fundamental part of this integration is the ability to spin up Kubernetes clusters on top of the Harvester clusters, and that's going to be supported for the both RKE, for the RKE1, RKE2 clusters, and we have building so much features into those Kubernetes cluster by default, like the CSI driver, which is able to access the native Longhorn storage performance, and the load balancer, which is you essentially just thinking about the ELB when you're connecting to the AWS and service, and those things, so many cool things we have building in this part. So that's really, I think, is going to be the highlight for our next release.
So kind of almost the ability to have Kubernetes instantly with the one-click release.
Sorry?
Almost like an easy button in Harvester to spin up a cluster of Kubernetes.
If you have so now the user experience is going to be like if you have your Rancher and you connect that to a Harvester cluster, and there's just basically one-click button for you to spin up Kubernetes clusters as VM on top of the Harvester clusters, and you can do all kind of configuration with that. That is, wow. And also that is Rancher supported Kubernetes clusters as well.
Awesome.
Yeah, I've got another question for you, Sheng. There's a question about Longhorn. I can't find it now, but do you have to use Longhorn? Of course, you're going to say, well, what are you going to say, Sheng? I know that is your baby. Longhorn and Harvester are both your babies.
Yeah. So what's the question about Longhorn?
I think it was. Is it possible to use storage other than Longhorn?
Okay. So the short answer and the long answer is no. And the reason is in fact very obvious. So one thing is the value we're providing as hyperconverged infrastructure is in fact including the software distributed storage, which is very, very important part. I would say for the features I have listed before, like using the back image to speed everything up and increase the storage efficiency, and the backup restore features, and those is all of the optimizations are not really can be easily done with other storage vendors. So that's why we are choosing to have the Longhorn and the only first-party integration solutions, and that is really going to enhance our user experience because, well, we can take advantage of whatever like the Longhorn features which happens can be used on the Harvester, and also something like line migration with raw block device. You simply cannot do that with any other storage out there. So this, as I demonstrate line migration, that's in fact a very neat trick with performance underneath to ensure that even a block device, not file system, a block device can be migrated to one node to another node. The endpoint can switch over and make sure there's no data corruption and stuff. So those kind of integration, you're not really going to get anywhere from whatever storage system you're using. And also, I want to give some teaser here, and I'm not sure how many people are going to know this, but I recently am working on some performance data on the Longhorn, and I will see really outstanding performance data when the Longhorn using on the bare metal with the SSD and NVMEs, and I'm going to have to write more and talk about more of that in the future, but this is just some teasers. And we know, and previously, some people might test the Longhorn, say, okay, it's probably not fast enough as compared to the others, and now we know there's something like in that test is heavily favored to cache mechanism and heavily favored to the very low slow CPU utilization. Those are things and basically make you didn't overlook the Longhorn's real performance, and if I can put it. So I was going to have a follow up on that, but just I will stop there about Longhorn.
Okay. Well, as we have one more question.
Well, there's a funny question. I don't think we have time for any more, but someone wants to see, he says, it was from Bala, can I see your t-shirt? It is funny. I don't know if you meant my t-shirt. I have a SUSE shirt on. Sheng, what's your do you have a funny shirt on, Sheng? Oh, yeah.
If you can see it, or it's like a reverse. This is, in fact, a t-shirt designed by William and the William Gymnast, and He is the product manager for Longhorn. For Longhorn, in fact, and the Harvester. And if you see it, this is not your grandparents' HCI, which I'm not going to say who that grandparent is, but yes.
Well, because Sheng, I like to ask silly questions. So I was going to ask you, how would you explain Harvester to your grandmother or grandfather or an elder or a 5-year-old? Can you do that in 30 seconds and then we'll hand it to Robert? Probably not. 30 seconds.
You really give up like tough questions. Yeah.
Think about that.
Right.
Maybe we'll talk about that one on office hours, which Robert's going to tell us about. There's so many questions, you guys. It's really awesome to see so much interest. And I know Harvester's got a lot of people's attention. So yeah, Robert's going to tell you how to find out more.
Awesome. Thank you.
All
right.
Yeah,
So
yeah. Go ahead.
as we wrap up our session today, this is our opportunity to ask you to get involved. So first and foremost is a star on GitHub. Find us on GitHub. It's github.com/harvester/harvester. Next is to download and use Harvester. We have competition. Get into your home lab. Get into any machine you have. Play with it. Use it. I've been doing it over the last couple of days, and I've thoroughly enjoyed it so far. If you find an issue, please log the issue in GitHub and join us at SUSE or community.suse.com. Some of the most important links that you'll see here is, the harvesterhci.io, our GitHub page as well, I just mentioned. The Slack channel, it's important to you to reach out to other Harvester users. We have an entire channel dedicated to Harvester. Post your questions in there as well. Follow us on Rancher Labs, and if you want to talk to Sheng anymore, you can follow him on Twitter at Yosker. You can follow me as well. I'm at Robert Sirk. Next week, we'll be talking about Hipper. And this Thursday, we'll have office hours. And if Sheng can join us or someone from his team, it'll be this Thursday at 1 p.m. Eastern time. And kind of, ability to get some of those extra questions answered that we didn't get to today. But if you have any of those questions, you can post them in the community. We'll get back to them as well.
Hey, Robert.
Yeah.
I think we actually are having office hours at a special time this week.
Are we?
Let me double check that. Yeah, I believe so, because Sheng has some of his teammates who might want to, I think, want to come. So, but I wanted to tell everyone, some of you guys might have come in through just one link to this event. If you want to see all the slides and the video, you need to sign up for the whole series, which is called Summer is Open. It's all free, of course. It's not like we're hiding anything. So if you go on community.suse.com under Academy classes, you can sign up for the whole series, and then you'll see the upcoming events, including the Thursday office hours, and then when we post this video and slides and stuff later today. But yeah, the office hours are going to be Thursday at actually 11 a.m. Eastern, 8 a.m. Pacific. It's a special time so we can have some guests from APJ region, I believe.
Yeah.
Awesome.
Okay.
Well, Sheng, thank you very much. On behalf of the community, we do appreciate your time. We know you're a very busy individual, so we want to thank you very much for coming.
Yeah, thank you, Robert. Thank you, CK. It's really been a pleasure and talking with you guys and answering those wonderful questions. We're really looking forward for you to try Harvester and give us feedbacks. And of course, if you want to dive more deeper into the Harvester and have communication with our engineer team, make sure you join the office hour on Thursday. Yeah.
Awesome. All right. Thanks, everybody.
Thank you. See you.